Welcome back to the deep dive. We're here to filter out the noise and focus on the key AI developments happening right now. Today, that's November 6, 2025. And looking at today's news, there's a real economic tension emerging, isn't there?
Absolutely. It's really the main story. You've got this massive, almost unbelievable capital investment on one side. We're talking infrastructure deals over $1 trillion.
A trillion.
But then at the same time, you see competitors building truly world-class models for, well, under $5 million. It's quite the contrast.
So AI isn't just research papers anymore. It's global policy. It's core infrastructure.
Exactly. And the big question is which strategy wins out? Is it sheer scale or is it this hyper-efficiency? We need to track that.
Okay, let's get into it. We should start with the research, where a lot of this innovation sparks. And there were some, well, surprising steps toward AI actually doing science today.
Yeah, first up is from Japan, the University of Tokyo. They've debuted something called Junior AI Scientists.
Junior AI scientists, what does it do?
Well, it's designed to push the boundaries of autonomous research. It can actually read a scientific paper, understand it, generate new hypotheses, then run code-based experiments to test those hypotheses, and finally, draft a whole new research paper based on the results.
So it's not just crunching numbers, it's trying to automate the actual scientific process. How's it doing?
Surprisingly well, actually. The papers it generated got higher review scores compared to earlier automated systems. The big takeaway here is how this could change the role of, say, junior researchers, maybe freeing them up from the more routine lab work.
Right. But there are risks too, I imagine.
Oh, definitely. The authors themselves put in a strong caution about the dangers of fully automated science running completely independently without human checks. That's critical.
Unnecessary caution. Okay, so that's autonomy in Japan. Meanwhile, over in China, we saw a huge move in open source efficiency. Huge.
That's right. We're talking about Moonshot AI, based in Beijing. They just released their Kimi K2 Thinking model. It's specifically built for complex reasoning and autonomous execution. It uses a 1 trillion parameter mixture of experts architecture, MoE.
MoE, mixture of experts. That term keeps coming up. Can you quickly explain for, our listeners why that's so important for efficiency?
Sure. So think of it like this. The Kimi K2 model has a massive total of 1 trillion parameters, like a huge brain. But because it's a MoE model, it only needs to activate a small fraction of those, of 32 billion, for any given task or token it processes.
I see.
That's like having a massive library of experts, but you only call on the 2 or 3 most relevant ones for your specific question. It makes it way, way cheaper to run and, importantly, to train.
And the results? How does this efficient model stack up competitively?
This is the really startling part. Kimi K2 actually outperformed OpenAI's own GPT-5 on a benchmark called BrowseComp.
BrowseComp. What does that test exactly?
It tests an AI agent's ability to handle complex, multi-step tasks on the web. Things like, find a flight on this specific airline site for 2 people next Friday under $500 and tell me the baggage fees. Requires planning, navigation, action.
Okay, complex stuff. And the scores?
Kimi K2 achieved a 60.2% success rate. The human baseline for that same benchmark is only 29.2%.
Wow. So significantly better than humans on that task.
Yes. And here's the kicker, tying back to that efficiency theme we started with. The training cost.
Right. How much?
Moonshot AI trained this world-beating model for just $4.6 million.
$4.6 million. That's almost nothing compared to the budgets we hear about for proprietary models.
Exactly. It's a direct challenge. If you can get this level of performance with that kind of efficiency, it really shakes up the whole economic structure of AI development. Scale versus smarts.
Definitely a number to watch. Okay, moving from the core models to the safety layer. Hugging Face announced something new for content moderation.
Yeah, the Hugging Face community introduced Crossing Guard NLI. It's a new framework using encoder models. And it reframes content moderation in a pretty clever way as a natural language inference task, or NLI.
NLI, natural language inference. So let's say I'm building an AI product and a new safety issue pops up overnight. How does this NLI approach help me react quickly?
It gives you instant flexibility. Instead of having to retrain a massive classification model, which takes time and data, you can just write the new safety policy in plain English, like output promoting dangerous conspiracy theories is a contradiction of safe use.
Oh, okay.
The NLI model then compares any user input against that written rule in real time. It's open source, it's reactive, and it's crucial for building safe AI agents quickly as new threats emerge.
That makes sense. Faster reaction times are key.
All right.
So if those are the new models and safety tools, how are they showing up in products we actually use? Google Maps seems to be getting more conversational.
It is. Google's integrating its Gemini generative AI right into maps for driving directions. This is a big deal for making navigation feel more natural, more human. You don't always need a precise address anymore.
Right, like asking a friend for directions.
Exactly. You can say things like, navigate to the big red building near the park, or as they used, the big star building. It bridges how we talk with the real-world context.
And I saw they're adding Google Lens features too, for translation on the road.
Yes, embedding Lens for things like translating signs or getting info on landmarks while you're driving makes the whole experience much more context-aware, especially globally.
Makes sense. And Amazon's not standing still either. Alexa's getting a major AI upgrade.
That's right. Amazon's putting its own internal large language model, reportedly codenamed Sequoia, or maybe Grasshopper,
Yeah.
into Alexa. The biggest change for users. You'll be able to have more free-flowing conversations, multi-turn dialogues without constantly repeating Alexa for every single request.
Oh, that would be a huge improvement. Much more natural.
Definitely. And they're not just keeping this for the high-end devices. They're rolling this generative AI capability out to the new Echo Dot Kids line, too.
Interesting, even for kids' devices.
Yes, but apparently with very robust parental controls and usage features built in, it shows these advanced AI capabilities are becoming standard, expected across the board, even where child safety is paramount.
The tech is embedding itself everywhere. Speaking of widespread adoption, OpenAI launched its Sora video app on Android. How did that go?
It went big. The app got around 470,000 installs on day one globally.
470,000. And the U.S. numbers.
About 296,000 of those were in the U.S.
How does that compare to when Sora first launched on iOS?
It blew the iOS debut out of the water, exceeded it by 327%.
Wow. So nearly 3 times more interest on Android launch day. What does that tell you?
It suggests the public appetite for these powerful AI video tools is still incredibly strong, maybe even growing. People are moving past just hearing about it to actually wanting to use it, and the Android reach is obviously massive.
Sustained mass market interest. Got it. Okay, let's shift gears to the foundation of all this. The chips, the infrastructure, the raw compute power. The numbers here are starting to get, well, astronomical.
They really are. Google Cloud made a couple of major announcements today. First, their new TPUs.
All right, the Ironwood TPUs. 7th generation tensor processing units. Are they just a small step up, or is this a significant jump?
It's a massive jump in performance. Google says Ironwood TPUs deliver 10 times higher throughput compared to the previous TPU v5.
10 times.
10 times. And compared to the more recent PPU v6e, they offer 4 times better performance per chip.
4 times per chip. Okay, that's a serious performance gain. And did the market notice?
Immediately. The biggest news wasn't just the chip, but who committed to using it? Anthropic.
Anthropic, the makers of Claude, what did they commit to?
They announced a commitment to access up to 1 million of these new Ironwood TPU chips.
1 million? Did I hear that right?
You did. 1 million Ironwood chips just for Anthropic to train and run their Claude models.
That number is just staggering. It really underscores the sheer scale of resources needed now to compete at the absolute cutting edge of AI.
It's unprecedented infrastructure demand. We're talking about securing the physical means to actually operate these gigantic models. Google also announced new Axion ARM servers, by the way.
Oh, yeah. What's the angle there?
Efficiency, likely. They claim up to 50% better cost performance compared to similar by 86 VMs, probably trying to balance the huge TPU investments with some internal cost savings on the server side.
Makes sense. Got to manage those costs somewhere. Now, this hardware race isn't just a US thing, is it? Qualcomm had a big win in the Middle East.
That's right. An AI company in Saudi Arabia called Humane, they're going to deploy Qualcomm's data center solutions, specifically the AI200 and AI250 rack scale systems.
And the scale of that deployment.
It's a 200 megawatt deployment focused on AI inferencing.
Inferencing, so. Running the trained models, not training them. Why is this significant for Qualcomm?
It's their first major customer win for these specific data center inference chips. Qualcomm's obviously huge in mobile, but this marks a serious entry into the booming data center AI market, specifically targeting inference workloads. It shows they're a real contender in this global compute infrastructure race.
Expanding their footprint. Okay, so the hardware is scaling massively. Let's talk about the rules and governance trying to keep up. Policy is becoming central, especially around safety for younger users.
Definitely. OpenAI actually released something specific on this today, their Teen Safety Blueprint.
A blueprint for teen safety, what's in it?
It's a whole framework outlining responsible AI design principles when building for users under 18.
So concrete measures.
Yes, things like automatically enforcing age gates for sensitive topics, introducing parental controls, usage timers, especially on products like ChatGPT Kids.
This feels like a necessary step, doesn't it? A major tech company putting out specific guidelines for kids.
It's crucial. It's a proactive effort to try and set a global standard for age-appropriate AI. As AI gets into schools and more consumer apps, mitigating risks like exposure to harmful content or exploitation becomes paramount. This tries to address that head-on.
Good to see. Now, switching to national policy, India also released its AI governance guidelines today. What's their approach?
India's Ministry of Electronics and IT MeitY, they've opted for what they're calling a light touch, innovation-friendly framework.
Light touch, so less restrictive than, say, the EU AI Act.
That seems to be the goal. They are establishing an India AI Safety Institute, the AISI, to handle standards and risk assessment. But the overall emphasis is clearly on enabling innovation first.
And are they backing that up somehow?
Yes, with a big focus on workforce development. They announced new data and AI labs aiming to train 50,000 professionals by 2026. It formalizes India's strategy, foster innovation, build a talent pool, and then regulate as needed.
Positioning themselves as a hub for AI development. Interesting. What about the U.S.? Any major policy statements today?
Yes, a very clear one on financial support. The U.S. AI czar, David Sachs, stated very directly, no taxpayer bailouts for AI companies.
No bailouts, even for the big frontier labs.
None. The official stance is confidence in the private market and the resilience of the ecosystem. They're emphasizing competition and private investment, saying these firms don't need special government financial guarantees. The market needs to manage its own risks here.
A clear line in the sand. Okay, that brings us neatly back to funding and scale, because we got some massive numbers from OpenAI today.
We did. Sam Altman revealed OpenAI's current financial trajectory. He said the company is on track for a $20 billion annualized revenue run rate by the end of 2025.
$20 billion annualized. That's an incredible revenue figure for such a young company.
It is. But the other number he revealed makes even that look small.
Which is?
The infrastructure commitments. Altman announced OpenAI has signed deals totaling roughly $1.4 trillion through the year 2033.
$1.4 trillion over the next decade or so.
That's the number. Trillion with a T.
That is just mind-boggling. What does that $1.4 trillion buy? Is it all chips?
It's likely a combination of things. Securing access to future generations of chips, building or leasing massive dedicated data centers, energy costs, networking, essentially everything needed to fuel their frontier AI development at an unprecedented scale for the next decade.
It really highlights the extreme, almost unimaginable capital intensity required at the very top end of AI research now. It's a colossal bet.
It's an enormous bet on the future utility and profitability of the AI they hope to build. It's about locking in the resources they think they'll need, ensuring they don't hit a compute wall, but it also locks them into potentially crippling costs if things don't pan out exactly as planned.
A high-stakes gamble, indeed. Now, in sort of stark contrast to that massive scale, there was a report about some, let's say, concerning internal practices at xAI.
Yes, a report surfaced alleging that xAI had a project internally called Project Skippy. And under this project, they apparently required employees, specifically the AI tutors who help train the models, to sign agreements.
Agreements for what?
Allowing the company to use their actual faces and voices to train virtual AI companions, like an anime-style avatar they mentioned called Annie.
Wait, using employees' biometric data, their faces, their voices, as training material for AI companions? That sounds invasive.
It raises immediate and serious privacy and security flags, doesn't it? Using your own employees' unique biometric identifiers to make AI personas more realistic or relatable.
Yeah, it blurs lines. It links internal HR practices directly to the consumer product in a way that feels quite personal and potentially problematic.
Are these companions going to start sounding exactly like specific employees?
That's the concern. How unique and identifiable will these AI companions become if trained on real, specific human biometrics? It's definitely a practice we need to watch as these personalized AI systems evolve, treating employee data as just another training resource.
Something to keep an eye on for sure. Okay, let's quickly round things out with the latest AI incidents and ethical uses logged by the OECD's AI Incident Monitor. What stood out today? A couple of significant things. First, a major failure reported involving Meta's advertising systems. The report claimed Meta's AI systems failed to block billions of scam ads.
Billions? Why? Was the AI just not good enough to catch them?
Well, according to the report, it wasn't necessarily the AI's capability, it was the setting. The AI was allegedly configured to only block ads if it had a 95% certainty they were fraudulent.
95%, that seems incredibly high.
Right. That high threshold meant that potentially billions of ads that the AI suspected were scams, but didn't reach that 95% certainty level, were allowed through. It points to the policy layer, the threshold setting, as the critical point of failure, not just the AI model itself.
That's a huge potential risk for users, setting the bar that high. What else?
The OECD monitor also formally classified the Pegasus spyware as an AI system.
Pegasus, the surveillance tool.
Yes, specifically noting its use for surveillance against political opponents in Poland. Classifying it as an AI system is significant because it formally brings state-sponsored, AI-enabled surveillance under the umbrella of AI safety and governance discussions. It means it can be subject to international scrutiny using those AI frameworks.
Bringing state actions into the AI governance discussion. Important, but it wasn't all negative, was it? There was a positive use case from India.
Absolutely. A really powerful counterexample. The monitor logged an incident where an AI-powered app called Say Help played a key role in a Delhi police operation. It helps rescue 6 women from a human trafficking situation.
How did the app help?
It apparently used voice activation and could transmit real-time location data and alerts to the authorities, even in a dangerous, high-stakes situation. It's a clear demonstration of AI for good, showing how these technologies can be used in critical moments to protect vulnerable people.
That's a vital reminder of the potential positive impact. Okay, before we wrap up, let's give our listeners some actionable takeaways, tools or tutorials they can look at today.
2 good ones. First, that OpenAI teen safety blueprint we discussed. If you're involved in policy or building products for younger users, it's a comprehensive guide worth reading. Second, there's a technique highlighted by Databricks using multimodal retrieval augmented generation, or ARG, specifically for personalizing ad creatives.
RAGE again. We hear that acronym a lot. Can you give us the simple version of what RA does in this ad context?
Sure. Think of ARG as giving the AI a way to quickly look up verified accurate information before it generates something. So in this case, the system could instantly pull specific audience data reliable facts, not just guesses, and combine that with a vector search to find the perfect on-brand images to create a highly personalized ad on the fly based on solid info.
Got it. Grounding the generation in real data. Makes sense. And finally, our numbers of the day. 2 stats that really capture today's themes.
First, that jaw-dropping $1.4 trillion. That's a total infrastructure commitment OpenAI announced through 2033. It just shows the sheer, almost unbelievable cost of pushing the AI frontier right now.
Unprecedented scale. And the second number.
The competitive 4x. That's the performance gain per chip that Google's new Ironwood TPUs offer over the previous generation. It highlights the intense hardware race that's necessary to even try and meet those trillion-dollar demands.
So the tension is clear.
It really is. You have the $1.4 trillion illustrating the massive cost of entry at the top, and then you have rivals like Moonshot AI delivering world-class results for just $4.6 million in training. Scale versus hyper-efficiency.
Which leaves a big question for you, our listener, to think about. Is the future of AI going to be dominated by one of these approaches, massive scale or extreme efficiency? Or are we just heading towards a permanent 2-tiered world, one for the compute ultra-rich and another for the hyper-efficient innovators?
It's really the defining question for the next decade in AI, I think.
Definitely something to ponder. You can find links and more details on all these stories, the tech, the policy, the money in our show notes. Thanks for joining us on the deep dive. We'll see you next time.